Welcome to Module 10b in our series on artificial intelligence. This module, like the last, discusses backpropagation. More specifically, this module will present the math or calculus required to actually perform backpropagation with a step-by-step demonstration, and we're also going to take a look at some simulation results. To properly apply the chain rule to backpropagation, as is the objective of this module, we must clearly define all of the functions relevant to this neural network, as well as the inputs or arguments that they accept. Remember that this module is a continuous of the previous, and we're using the same 4-node neural network example from that module for this one. So we have 4 functions that we're going to look at. The first is a single component of the error. Now, if we remember from the last module, we saw that there were 2 components of our error. There's E5 and E6. E5 is associated with the state of output node 5. E6 is associated with the state of output node 6. So E superscript M is a function of 2 arguments, the ideal state of node M, as well as the calculated or estimated state of node M. And here we can see the error function defined by the mean squared error. The second function type is the total error. The total error is merely the sum of the 2 relevant components, E5 and E6. Each one of those function components accepts 2 inputs, so the total error accepts 4 inputs: the ideal state of nodes 5 and 6, as well as the estimated or calculated state of nodes 5 and 6. The third function that we need to review is the state of an output layer neuron, or an output layer state. So what we see is X superscript M, the state of node M, is dependent on 6 different values. We have all 4 of the output layer synapse weights, which we can represent collectively as W subscript OL, as well as both of the states that feed into the output layer, which I represent here as X subscript OL. The fourth type of function we need to look at is the state of a neuron in the hidden layer, or a hidden layer state, still represented by X superscript M, still a function of 6 arguments, but these arguments are different. So instead of it being defined in terms of the output layer synapse weights, we define them in terms of the hidden layer synapse weights, and instead of being defined in terms of X3 and X4, the states that feed into the output layer, we define it in terms of X1 and X2, the inputs that feed into the hidden layer. Next, we dive into the actual backpropagation process. Specifically, we want to define the gradient of the total error with respect to a synapse weight in the output layer. We'll deal with the hidden layer in a second. We begin with step number 6. Why step number 6? Because the last module, and this module is a continuation of the last, it performed the beginning of the backpropagation process. It defined the example we're going to use, it defined the neural network model, it defined the initial conditions of all the synapse weights, and it performed what we call the forward pass, which yielded all the network states and errors associated with a training data set.